Hello there and welcome back to another video. In today's video, I'm going to be benchmarking and comparing 5 different Intel Core i5 CPUs from 5 separate generations. I've got an i5-6500, i5-7500, 8500, 9400, and a 10400 to test out today, giving a solid representation of the used i5 CPUs that are easily and cheaply available on local marketplaces or eBay. So hopefully this video will be able to provide some meaningful insight as to whether or not that i5-7500 is worth an extra 20 bucks over the 6500, or if it's a worthwhile upgrade from a 7th gen chip to an 8th gen chip, even though the price difference might be kinda large. Now, before I get into all of the exciting data that I'll be collecting, there is a little bit of setup to run over first, just so you can understand both the limitations of the testing I'm doing and the environment in which it'll be done. First off, as you've probably noticed, I've collected an array of different systems with these chips in them, which obviously means that these comparisons are not going to be perfect 100% apples to apples tests. This is because each of these different models, and definitely the different brands, will have different cooling solutions and BIOS settings, such as power limits, among other things that will have the power to slightly affect the CPU's performance. This is also the reason that I'm not doing any power efficiency testing to appease some of the home server people, as due to the completely different system models represented, things like idle and even under load power can't be effectively compared. Additionally, different CPUs support different memory speeds, so while I'll be ensuring that all of the memory installed in the systems is identical, that being 2 8GB sticks of DDR4 2400 MHz RAM running in dual channel, I cannot guarantee that every system will run this memory at 2400 MHz. In a similar realm to memory, I will also be installing 256GB Western Digital SN730 SSDs into each of these computers to ensure that the storage variable will be controlled. Another note on storage, for the DaVinci Resolve rendering tests, all of the media is being pulled from an external USB 3.0 SSD. And the final bit of information to keep in mind is that for each test, I'll be installing my RTX 3050 6GB low profile card into the system using a PCI Express riser to ensure that it can be plugged into an X16 slot in every computer for even performance. This will allow me to test these CPUs in applications that they wouldn't be able to run well or at all without a discrete GPU, such as 3D Mark, some games, and Fusion 360. Oh, and real quick, before I start running through each of the tests individually, if you find yourself watching and wanting a better comparison between each CPU, check out the end of the video, where I've compiled all of the data and done a large comparison across all 5 chips that's easier to make sense of. And with that, let's get into the testing. Starting with the Optiplex 7040 that has an Intel Core i5-6500 in it, a 4-core, 4-thread, 6th generation CPU. With a fresh installation of Windows 11, let's check out how the CPU scores in Cinebench R23. In Cinebench R23, the i5-6500 got a multi-core score of 3,375 and a single-core score of 921. This places it as a pretty weak CPU overall, and I expect it to struggle quite a lot in the upcoming productivity benchmarks. First though, let's check out one more synthetic benchmark to set some more baseline numbers that can be compared as we go on. I chose to use 3D Mark TimeSpy for this, less so for the overall score and the GPU score, and much more because it provides a CPU score as well. We will look at the GPU score and the overall scores at the end to see if there are any interesting trends in that data, but for now, let's just look at this system's CPU score, which ended up being 3,289. Alright, now we can look at some more real-world productivity benchmarks, and I've chosen to use a DaVinci Resolve timeline export and an in-canvas render in Autodesk Fusion for these 2 tests. This is because it was relatively easy to figure out a way to run these softwares that allowed for repeatable, comparable benchmarks. In DaVinci Resolve, I exported the timeline from my cheap UPS's video, which is chock full of 4K 24fps footage. And I exported it at 4K 24 frames per second in H.264 to ensure that I was heavily leaning on the CPU to export as opposed to the GPU. The i5-6500 exported this timeline in 26 minutes and 8 seconds. In Fusion, I chose to run an in-canvas render of a 3D model, which is a fully CPU-dependent task, and I ensured to choose the exact same model and viewpoint for each system. I timed how long it took each system to reach iteration 100, and this system took 147 seconds to reach render iteration 100, making it quite a slow renderer, though still usable. And with that, we're on into some gaming benchmarks. For these benchmarks, I ran the games at incredibly low settings to remove the GPU as the limiting factor for frame rate. This intentionally caused CPU limitation should hopefully demonstrate the difference in performance between CPUs quite well. I will also note that intentionally removing the GPU as the limiting factor in frame rate is also the reason that the only games I tested were esports titles, as those should be incredibly easy on the GPU, making it easier to force that CPU limitation. I tested 2.5 titles, those being CS2, Fortnite, and the half test is Valorant. I'm considering Valorant as a half test because it only ran on 2 of the 5 systems due to issues with Vanguard's anti-cheat and the way it interacts with Secure Boot and TPM 2.0. In any case, let's check out how the 6500 does in CS2. In CS2, at the lowest settings, but with no FSR upscaling, this system managed an average frame rate of 89.5 FPS with a 1% low of 51.6 and a 0.1% low of 26.4. So, a usable experience, though a frame rate that I definitely suspect will increase with more powerful CPUs. In Fortnite, at the lowest setting and 100% 3D resolution, the 6500 got an average frame rate of 86.9 FPS, with a 1% low of 21.3 and a 0.1% low of 4.7. Though it's worth noting that even though the average looks great, this game was really hard to play for the first few minutes of any match because it seems that the CPU was so pinned out, even at minimum settings, that it was struggling to load assets from storage into the GPU's VRAM, leading to things like this. As for Valorant, well, it didn't run on this system due to the fact that it doesn't support the security features required for Windows 11 and therefore also Riot's Vanguard. So that wraps up the benchmarks for the i5-6500. While being an old CPU at this point, this chip still held up well considering that it can be picked up in a complete system for under $50 quite easily. And while it doesn't perform crazy good, it still performs acceptably for a lot of use cases. But the real question is, for $20 or $30 more, is it worth upgrading to a system that comes with an i5-7500? Well, let's find out. I do predict, and I made these predictions before beginning testing, that this chip will not perform much better than the 6500. This is because the 7500 is still a quad-core chip that doesn't have hyperthreading, and it's only going to be a generational upgrade in single-core performance that really gives it an edge. In any case, let's set up the Lenovo ThinkCentre M910S that I have for this CPU and give it a go. Starting again with Cinebench R23, this chip scored 3,363 points in multi-core and 986 points in single-core. The multi-core score was a few points lower than that seen with the 6500, though it was by a mere 12 points, which places it securely within margin of error. The single-core score jumping from 921 with the 6500 to 986 with the 7500 is a noteworthy increase though, indicating about a 7% performance uplift with the 7500. Moving into 3D Mark TimeSpy's CPU test, a noteworthy improvement over the previous CPU score of 3289 can be seen, as the i5-7500 scores 3532 in this test, indicating again about a 7% improvement over the 6500. As for the productivity benchmarks, starting with DaVinci Resolve timeline exporting, there was a small bit of time shaved off of the overall render time with this new CPU. The timeline exported in 23 minutes and 8 seconds this time, as opposed to 26 minutes 8 seconds, making it exactly 3 minutes faster. In Fusion, the 3D model reached render iteration in 130 seconds with this chip, a solid 17 seconds faster than with the 6500, which adds up if you're performing several renders. Now, let's check out CS2, where the system got an average frame rate of 106.1 FPS with 59.8 and 29.3 as the 1% and 0.1% lows respectively. So a noteworthy improvement over the 6500 and enough to pass the 100 frames per second mark. As for Fortnite, which will be the last game on this CPU as, again, Valorant wouldn't run, there was a small but noticeable performance delta between the 6500 and 7500. The 7500 got an average frame rate of 91.3 FPS and a 1% low of 22.7 with a 0.1% low of 11.5. So large improvements to the percentile lows, but only a few FPS different on the average. Plus, this system still struggled with loading assets efficiently, making it hard to play for the first few minutes of a match. Alright, that's 2 systems down. As I expected, there is a small performance increase with a 7500, but nothing too major. However, moving into this next system, which is kitted out with an i5-8500, I expect that there will be an absolutely massive performance delta. This is because when Intel moved into their 8th generation chips, core counts were increased for the i5s. They went from being quad-core chips without hyperthreading to 6-core chips, though 6 cores with hyperthreading was still only reserved for the i7. So there's now been a 50% increase in core and thread count with the jump from the 7500 to the 8500, and of course, the standard generational performance increases apply as well. Furthermore, the 8500 is the first CPU of this comparison that officially supports Windows 11, and this combined with the increased core count is reflected in the steep price increase from a system with a 7500 in it to a system that has an 8500. In any case, let's see if that 50% core count increase actually leads to anywhere close to a 50% performance increase, starting with Cinebench. In multi-core, the 8500 scored 5,452 points, and in single core, it breached the barrier to 1,000 with a score of 1,030 points. That's a 62% increase over the 7500 in multi-core, but only about a 4% increase in single core. Still quite impressive, and that multi-core performance will likely make productivity tests run way faster. In 3D Mark, the CPU score for this chip jumped massively again, this time becoming 5,182 points, showing a similar performance increase to the performance increase seen in Cinebench. Moving into the productivity tests, it's time to see how fast this system exported the DaVinci Resolve timeline. And oh boy was it faster than the other two chips. The previous best time of 23 minutes 8 seconds has now become the 8500's time of 15 minutes 47 seconds, around 7.5 minutes faster. Pretty darn impressive. Continuing into Fusion, a similar scale of improvement was seen here as well, with the 7500's render time of 130 seconds being beat by the 8500, which comes in with a render time of only 79 seconds, meaning that we're officially rendering at a rate above 1 iteration per second now. So yeah, a pretty massive improvement in both the synthetic benchmarks and the real-world productivity ones. Not surprising at all to me, considering that softwares such as these are getting a lot better at utilizing more cores and threads, so a jump from a 4-core chip to a 6-core chip is almost always completely utilized, resulting in a massive improvement in performance. Finally, for the 8500, let's see if 2 more cores makes a difference in gaming. Starting in CS2 again, we gained a whole 30.8 FPS with this chip over the 7500, as the new average is 136.9 FPS. That's a meaningful jump if I've ever seen one. Now, as for the percentile lows, they increased proportionally, with the 1% low being 68 frames per second and the 0.1% low being 33. Moving into Fortnite, the average frame rate increased with this chip an absolutely absurd amount, that amount being a whole 58 FPS. That's like a whole playable game worth of improvement. The actual numbers are that the average frame rate was 149.3 FPS now, with a 1% low of 8.3 and a 0.1% low of 2.3, but wow, is that ever a performance increase. Finally, let's set our Valorant baseline, as this is the first system that will run it. In Valorant, at the lowest settings while still being native 1080p, this system got an average frame rate of 261.2 FPS, with a 1% and 0.1% low of 147.1 and 53.8 FPS respectively. And that concludes the 8500's benchmarks. And I've got to say that if you value higher performance in your workload, making the jump from a 7th generation i5 to an 8th Gen 1 will be worth it. But now, let's move on from the 8500 to the chip that I have representing Intel's 9th generation of Core i5 CPUs, the i5-9400. Now, before I get a bunch of comments about this, I do want to address that yes, it would have been better if I had a system with a 9500 in it instead, as that's a slightly higher end CPU that matches the tier of all the previous CPUs in these tests. However, those systems were quite expensive to purchase when looking online, and I was mostly trying to create this video using PCs that I already had on hand for other projects, meaning that this is what I ended up with. Anyway, let's get to testing this i5-9400 in a Lenovo ThinkCentre M720E in Cinebench R23. This CPU in Cinebench managed a multi-core score of 5,724 points with a single core score of 1,084, indicating an incremental improvement over the i5-8500. This isn't surprising to me, as the 9400 is still a 6-core, 6-thread chip, and it's only a single generation newer than the 8500. Checking out 3D Mark TimeSpy again, this CPU actually exhibited included a small dip in performance compared to the 8500 with a score of 5106. This is interesting and a theme that will show up more than once in these tests for this CPU, leading me to wonder if the M720E system that this chip is installed in might be causing some performance issues. As for rendering a timeline in DaVinci Resolve, the i5-9400 was able to export the timeline in 15 minutes 38 seconds, which is so close in time to the i5-8500's 15 minutes 47 seconds that it's, in practicality, identical. Moving on now into rendering in Fusion, the exact same in-canvas render took 80 seconds on the 9400, 1 second slower than the 8500's time, indicating a very similar performance between these two chips, at least so far in these practical tests. Now, as for the gaming benchmarks, in CS2, the system with the 9400 ended up with an average frame rate of only 118.9 FPS, with a 1% low of 15 and a 0.1% low of 11.8. This is a significant decrease in performance compared to the 8500, and I'm not sure what's causing this. Additionally, there was a strange rhythmic stutter in the game that I was completely unable to get rid of, which hasn't shown up at all on any of the other systems tested. Moving into Fortnite, yet again, there was a large decrease in performance with this CPU in this system. The average frame rate was 133.6, and the percentile lows were 19.7 and 9 FPS respectively. So far, the benchmarks for this chip, especially the gaming ones, are really strange to me. I am not sure what is causing them, and I honestly severely doubt that is the i5-9400's fault, and instead believe the blame might belong to the Lenovo Think Center, but I'm unsure. Plus, you might be wondering why I haven't mentioned Valorant's performance yet, and that is because for some reason, even though Secure Boot was enabled, Vanguard was just not having it and wouldn't let Valorant run on this system. So yeah, a bit of a disaster for the 9th generation chip, but again, I'm not sure that this can be considered a fault of the CPU itself, and is much more likely to be due to the system that the CPU is in. In any case, I don't have much more to say on this chip, so let's move on to the 5th and final CPU today, the i5-10400. The i5-10400 marks a very important milestone for Intel, which is the point at which the i5 became a 6-core chip with hyper-threading enabled. The 6-core 12-thread chip is an incredibly common CPU type, literally all over the place. Just think about basically any mainstream Ryzen 5 to ever exist, and just how many of those are out there, and know that those are all 6-core 12-thread chips. Up until the 13th generation, where Intel did not create any 6-core desktop chips, the 6-core hyper-threaded i5 has been a bit of a staple of budget gaming. The 11600K, which actually held up decently compared to the 5600X at the time of its launch, and of course the 12400F and non-F, which are still some of the best budget gaming chips if you're buying brand new. So how does this i5-10400 hold up in an office PC? Is the gap between 8th and 9th gen and 10th gen going to be as big as the gap between 6th and 7th gen and 8th and 9th gen? Well, let's find out. But first, my prediction, which was that in productivity, there would be a major increase in performance, but in gaming, there would still be a meaningful uplift, especially in Fortnite, but it would be less so than the jump from 7th to 8th gen. So, starting out in Cinebench R23, the 10400 scored a multi-core score of 7,773, and a single-core score of 1,144. So yeah, a pretty darn noteworthy uptick in performance over the previous best performer, the i5-9400. The numbers work out to be about a 36% increase in multi-core and a 5.5% increase in single-core. That is, over the i5-9400's numbers. Running a quick pit stop by 3D Mark, because there's not too much to be said here, other than that we're back on the trend of increasing on past generations now, with a new high score of 6,985, representing a pretty massive performance increase with this chip. Into DaVinci Resolve renders now, this chip was the fastest exporter by far, with a final export time of only 11 minutes and 36 seconds, a full 4 minutes 2 seconds faster than the i5-9400. Then, with Fusion's in-canvas render, this chip reached iteration 100 in only 59 seconds, which makes actually using the in-canvas render feature, a quick, easy way to preview a render before making a full-res version, actually efficient enough to use to, well, use. And that leads us to the last 3 gaming benchmarks before the final conclusion and comparison between these 5 CPUs. So let's check out the 10400 CS2 performance, which ended up being an average frame rate of 156.9 FPS, setting a new top performance. The 1% and 0.1% lows were 68.1 and 34.3 FPS respectively. Dropping into Fortnite one last time, this system finally beat the major issue of assets not loading fast enough for the experience to be good, all the while while slamming out an average frame rate of 153 frames per second with a 1% low of 50.4 and a 0.1% low of 0.9. And finally, only the second time that Valorant has been successfully tested on one of these systems, let's check out how the 10400 did here. The average frame rate in Valorant was 258 FPS with a 1% low of 133.2 and a 0.1% low of 51.9. So, while a solid performance, not much different than the performance that the 8500 managed in this game. Whew. And with that, we're officially done running through all of the individual benchmarks. That was quite boring if I do say so myself, but if you're still with me, let's wrap all of the data I collected up into a neat little package and make some overarching comparisons between these CPUs. Starting out with the synthetic benchmarks, specifically Cinebench R23. In multi-core performance, the differences and similarities between the 5 generations can be really clearly seen. 6th and 7th gen chips are very similar in performance, likely due to the fact that they're both just 4-core, 4-thread chips. Once moving into the 8th gen i5, a massive improvement can be seen with the addition of 2 more cores to the chip, though 8th and 9th gen chips perform very similarly as they're both 6-core, 6-thread chips. Finally, the jump into hyperthreading between 9th gen and 10th gen further pushes multi-core performance up. While of course, these synthetic benchmarks don't perfectly translate into real-world differences all of the time, these multi-core numbers indicate that there are basically 3 performance tiers within this generation window of i5s, and you just have to choose where your budget puts you. The tiers end up with 6th and 7th gen grouped together as the lower performance chips, 8th and 9th grouped together as the medium performance chips, and 10th on top being the highest performance chip. So for purchasing within, say, the medium performance group, just choose whatever chip is cheaper at the time, whether that's 8th or 9th gen, depends on the day, and you'll probably be fine with either one. Moving on from multi-core, however, and analyzing single-core performance, because that's also important for different applications, it's actually really interesting to see how incredibly linear the increase from generation to generation is. I really didn't expect this, but it seems like the rule for single-core performance just might be more generation, more faster. And this ends up happening in practically identical steps per generation, regardless of whether you're going from 6th gen to 7th or from 9th to 10th. In 3D Mark, the CPU score metric shows a very similar trend to the Cinebench multi-core score, with big jumps between 7th and 8th gen and 9th and 10th gen chips, but similar performance between the 6th and 7th gen and the 8th and 9th gen. Again, the 9th gen chip's performance is a bit of an outlier here, but nevertheless, it still follows this basic trend somewhat well. Looking at the GPU score from the 3D Mark tests, a metric we haven't seen yet, just to see if there are any interesting trends there, it doesn't look like there's any meaningful difference across generations with the 3D Mark GPU score. The only outlier is the 9th generation system, which should be a bit of a given at this point. As for the overall 3D Mark score, it follows the CPU score's trend quite closely, so nothing too meaningful to pull from here, I don't think. So now, let's move on to the 2 actual productivity tests in real-world applications, and I've chosen to graph these a bit differently to really show the improvement across these systems. In DaVinci Resolve, it can be seen that while the overall trend is similar to the trends in Cinebench multi-core and 3D Mark CPU score, and that is the difference between 6th and 7th gen. Interestingly, the 7th gen chip pulls ahead of the 6th gen chip by a much larger margin than it did in nearly any other test, making the choice between 6th and 7th gen more important for prospective video editors than any other test would indicate. Of course, from 7th to 8th gen, there was a massive improvement due to the core count increase, and 8th and 9th gen were very similar in performance. Finally, the 10th generation chip, unsurprisingly, pulls ahead of all the other chips, but not by as fat of a margin as the 8th gen pulls ahead of the 7th. Moving on into 3D model render times in Fusion, we can see a nearly identical trend to the DaVinci Resolve trend. There is a larger gap between 6th and 7th gen than the synthetic benchmarks would indicate, and there are of course the 2 large improvements when 8th and 10th gen chips came out. Plus, the 8th and 9th gen chips are still performing practically identically. And that's all of the synthetic and productivity benchmarks completed. So let's check out some of the gaming benchmarks and see how the different chips affected that. Starting with CS2, if we ignore the 9th gen system, which is known to have been an outlier in other tests as well, there is a pretty consistent positive trend in the average frame rate with higher generation chips. There is a larger than normal gap between 7th and 8th gen, as has been seen everywhere else so far, but overall, the performance trend isn't too far from linear. As for the percentile lows, again, ignoring our outlier in this game, there is a very, very minor positive trend as the generation increases for both the 1% and 0.1% lows. However, this doesn't equate to much and certainly isn't as noteworthy a trend as the trend in the average frame rates. Switching to Fortnite now, the trend in this game is actually really interesting. There only seems to be one major jump, and again, we're mostly ignoring the 9th gen outlier, though it's not as far off track in this test as it was in the others. The trend in this game is that 6th and 7th gen chips performed basically identically, and while their average frame rates were fine, they had issues of their own with loading assets effectively. Then, for the other 3 chips, it seems like the performance was about identical, but of course way higher than the 6th and 7th gen chips. The only noteworthy difference between the 8th, 9th, and 10th gen chips is that the only chip that fully avoided the asset loading issue was the 10th generation one, which is definitely worth keeping in mind if you're planning to play a lot of Fortnite, because that issue did cost me several matches. Quickly looking at the percentile lows, there isn't too much of a trend here to talk about, other than that they're mostly identical up until the 10th gen chip, which ends up having a much more acceptable 1% low than any of the other chips by a pretty massive margin. And finally, let's talk Valorant, which only ran on the 8500 and 10400. So quite a useless benchmark in the end, and interestingly, the performance between these two chips was, for all intents and purposes, identical. So if you're building a Valorant machine, save some cash and grab an 8500 instead of splurging for something like a 10400. Now, before I move on from Valorant, there is one thing that this mostly failed benchmark did point out that is really worth bringing up, and that is that within the range of i5 generations that I chose to test today, some of them natively support Windows 11 and some don't. This does have the power to affect certain things. In this case, whether or not Valorant could or could not run, which was seen on the 6th and 7th gen chips and also the 9th gen chip, but that seems to be a different quirk. So note that that chip isn't really included in this conversation. In any case, this does show that it might be important to go 8th gen and above for maximum future compatibility if you think that your applications and workload may demand it. But with all that said, I think I'm going to end this video here. I was intending to provide a solid enough amount of information with this video that anyone watching would be able to get a good idea of the Core i5 that might be best for them. And if you were looking for a purchase recommendation, I'm sorry, but I don't have one. Take a look at the data and your budget, and you should be able to figure out what chip will be best for your purpose. Then let budget decide which one you can afford and go for it. Or maybe this data is convincing enough to cause you to wait and save up a little more to maybe get an 8th gen chip over a 7th gen one due to that insane performance increase. Well, that's all that I have for you in today's video. I hope that you were able to at least enjoy it and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.